My name is Ian Dennis Miller from the University of Toronto, and today I'm going to be speaking about unfriending on social media and the way that this can produce echo chamber-like dynamics. So, has anybody ever unfriended you for your political beliefs? Or have you ever unfriended anybody else? What happens when friendship ties are cut, but political ties remain? So, I've run some computer simulations which suggest that in the absence of friendships, the population bifurcates along party lines. And when friendships are permitted to cross party boundaries, then the population does not fragment in the same way. And finally, I'm going to share some surprising findings that occur when new friendships are created within these simulations. So the research methods that I use for this study include simulation methods, agent-based modeling, memes, and in particular an epidemiological model of culture that I developed, and networks, both social and political. Now I'm going to describe each of these in the following slides. So the simulation methods that I use are based around the idea of running lots of different scenarios that I have constructed to represent different aspects of what I think the reality is of the thing that I'm trying to study. In this case, I'm going to be changing the behavior of the network or the way the network operates. I call these network interventions. They're also called exogenous shocks in different literatures. And the basic idea is to repeatedly run these scenarios within the simulation. Since the behaviors of the agents are stochastic, then this results in a chaotic system that produces emergent phenomena that are interesting to observe. Agent-based modeling is a methodology that is found in ecology, sociology, epidemiology, behavioral economics, social psychology, and beyond. The specific framework that I use is called NetLogo by Uri Bolensky at Northwestern University. This provides us with an actual environment for the agents to operate within. It gives us agents. It also gives us a notion of time and a concept of units of time moving forward. So these are called steps or ticks. And finally, the NetLogo framework makes it simple to monitor or observe the performance of these simulations so that we can analyze the results later using a statistics package. NetLogo gives us a great framework called behavior space, which is useful for constructing experiments that involve running repeated simulations with different conditions. And finally, the descriptions of my agents is derived from my own work, Agent Space, which can be thought of as a complementary framework that enhances behavior space by providing a reusable and shareable set of agents corresponding to the human population that all agent-based modeling can make use of. And this is online at peopleapi.com. Now, memes, as Richard Dawkins originally conceived of the term, are units of culture that can be reproduced with mutation, so they can be changed a little bit along the way. And memes are useful for modeling phenomena that we come to call viral, especially through online social media networks. My specific model of culture is derived from a literature that I found describing infection and immunity dynamics in Epstein and Axtell's seminal work, Sugarscape. I've taken this notion of an immune system and adapted it to be somehow analogous to preferences. Pepe the Frog is an example of an influential meme that was used extensively in the 2016 U.S. presidential elections, and maybe we'll talk a little bit about that later. So the final major component of my research methods is the use of networks. In these simulations, I include a social network that was constructed as a function of a small world algorithm, and also a political network that was constructed using a preferential attachment algorithm. This political network this preferential attachment algorithm produces a hierarchical network topology that's kind of like the way a political structure might look. It's more of an approximation. And then finally, there's a proximity network, which occurs as agents become close to one another, and this permits them to sort of have this ephemeral bumping into one another dynamic. So the two types of networks exist at the same time, and here I'm visualizing the same sets of agents, but the two different types of networks that connect them all. So on the left are friendship networks, and that's a common visualization of a small world network. And on the right are two political parties that it's evident from looking at the arrows and where they all point that a couple of the agents in the political parties network have a higher integrity than some of the other agents. Those agents with the high integrity are going to become designated politicians, and the other agents will be able to communicate with them. So the fundamental action of the agents in this network is that they are cultural sharing machines. Now, we are going to be talking about political phenomena, but what the agents are actually doing is they are sharing. And the way that they share depends on the type of network that they use to share. So when agents are using the friendship network, then they can share memes to the people that they are friends with, who may in turn pass those memes along to yet other people. And when agents literally bump into one another, they can just sort of casually share with the people, with the agents that they bump into. But along the political network, this is a directed network with directed dynamics in which normal agents, non-politician agents, are able to submit memes in the form of a petition to their political representative, and then politician agents are in turn able to communicate memes as speeches, which are broadcast to all of their constituents all at the same time. Now, agent culture is conceived of as preferences, and as I've said, the preferences are loosely related to a biological, epidemiological immune system. These preferences cause agents to attend to different aspects of the memes that are shared with them, and as a result of the memes that are shared to an agent, that agent's preferences will change slightly over time. Now, this is the kind of the basic dynamic or the basic assumption of advertising, in which the belief is that you share or you broadcast a message often enough, and people come to recognize it. People come to maybe like your brand. This is not exactly the same dynamic, but that's the gist of what's going on. So agents also have a concept of memory. Agents are able to forget memes after a period of time. And so that this means the absolute death of memes is possible. They can be completely forgotten from the whole network. And mutation is supported in the nature of the sharing mechanism. This means that one bit of a meme can be flipped from a 0 to a 1 or 1 to 0. Now, let's walk through what the simulation environment looks like. So I've constructed a special map here with a town square. This is in the lower left-hand corner. And the important dynamic involving the town square is that when an event happens in the town square, every other agent in the town square who's currently there is able to witness that event. And agents then make memes, and they derive kind of a memory from whatever it is that they witnessed. And that's what they actually share. So at the beginning of the simulation, agents are randomly distributed across the environment, and friendships and political networks are constructed before the simulation starts. So these networks are not grown as the simulation runs. And for the purposes of the many repeated runs that I'm doing, there's only 50 agents per simulation right now. So this is exactly what it looks like. In the corner is town square. There's an agent that happens to be in the town square, so that agent is able to witness whatever events might happen in the town square. Another agent that's outside of the town square can only learn about what happens in the town square by hearing about it, either through their friendship network or by bumping into somebody or by hearing about it from a politician. This icon is slightly larger. That is designed to indicate that this particular agent is a politician. And you see over here, there's some text overlaid onto another, actually that's a politician agent, that says speech. What it means is that agent right now is in the process of delivering a speech. So these are the exact same agents in the same location, and I've simply turned on the visibility of the political network. So I showed it to you previously with different agents having different in degrees. Well, okay, this is a politician agent, the one that was delivering the speech, but compare that to this other politician agent who has a lot more arrows going into them. That's a higher in degree, and that means that this second politician is more influential. They're higher up the chain. And when I turn on the friendship network, it becomes visible that all agents are connected through these friendship ties, and it might not be immediately obvious, but these ties do not follow political lines. These ties cut across political boundaries. So that is the same agent that was delivering a speech before, and you can see that they're going to be connected through the friendship network to different agents who are not their political followers. Okay, so here's an animation that is going to demonstrate everything that I just showed. So we start the demonstration, set up the network, and we're going to start stepping through time. So the agents in the town square have seen an event, and it said seen it. And so now you can see other agents are petitioning, and as you see text popping up on the video, that's the agents actually enacting sharing behaviors. So the biggest thing that I'm measuring as a product of these simulations is the heterogeneity of the culture, whether the agents have similar beliefs or different beliefs. And I've developed a numerical value that captures this characteristic. It can be conceived of as a similarity score of the agent's preferences, calculated across some set of agents. Now I can do it across political parties, or I could calculate the similarity across the entire simulation. And this is, you can conceive of this as the cross product of vectors. So that is a way of for us to capture the differences between those agents. So the differences are heterogeneity, and the similarities are homogeneity. So the way that we interpret heterogeneity is when heterogeneity is high, then agents have different and varied preferences. When heterogeneity is low, then agents produce and respond to a narrow set of memes. So low heterogeneity is the same thing as high homogeneity. These are inverses. And low heterogeneity is it corresponds to groupthink and echo chambers. Both of these are situations where the same types of thoughts are bouncing around. We can also think of homogeneity as being kind of like polarization. So when memes from one party become incompatible with members from the other party, that is, you could share them to the other people, but they don't ever like them and they don't ever reshare them, then that's one way of operationalizing the idea of polarization. And a consequence of the way that culture works and a way that the sharing mechanisms work within this simulation is the production of an echo chamber. And the reason for this is that the information exposure, the memes that agents are exposed to, shapes the preferences slowly over time. And as those preferences are shaped, then agents become more or less able, willing, if you will, to engage in sharing with members of different political parties. So let's look at some of the output from the simulations, and I'm just going to prep you for how this is designed to be interpreted. So on the left, we have a plot that depicts the number of memes over time. So time is along the x-axis, and count, or the quantity, is on the y-axis. And you see there are three different colors, one corresponding to petitions, so that's agents asking their politician for something, one corresponding to the number of speeches that are given, and another one corresponding to the number of shares that occurred. So I'm going to point out this point in time where you see the number of shares is increasing over time, and then suddenly it becomes a horizontal line. The number of shares no longer increases. That right there is the product of a network intervention or an exogenous shock that I am applying within the simulation. So what that means is, in this case, I'm disabling sharing at that point. And you can see that there's no more sharing that occurs after that point. So the plot on the right is heterogeneity over time. And the basic idea is that it's for all of these simulations, it starts off high and it gets low. So I'm also visualizing heterogeneity within both of the parties. And so what this specific plot shows is that in both cases, homogeneity increases for both parties. So, okay. Now, I'm going to discuss 4 basic scenarios here. In the one case, I'm going to ask what happens when friends stop sharing to one another. This is the unfriending, or the cutting the friendships scenario. And then in another case, I'm going to permit agents to share only along the political network initially. And then later on, I'm going to turn on sharing along the friendship network, and we'll see what happens there. And then I also want to discuss 2 other kind of interesting cases of emergence that occur in these simulations, even when I don't perform any specific network interventions. So the very first scenario I call the cut friendships scenario. Now, this is when we imagine if we stopped being friends with one another and we only listened to politicians. Now, I'm actually going to cut all friendships all at once. That's a little bit of an exaggeration of what probably happens in real life, where we gradually cut friendships, we gradually add friendships. And so this is a network intervention, or an exogenous shock, that disables friendships after 1,000 time ticks. And in practice, agents are going to no longer share via the social network. And so I have an arrow here pointing to the plot that I showed earlier, where shares increase over time, and then at a certain point, the number of shares remains constant. There are no other shares after that point. And what we see is the moment of the intervention, the moment when I make this change, then we immediately see heterogeneity starts to dive. In this case, party 2 takes a dive first, but they both start decreasing in heterogeneity. And at the end of the graph, it's a much lower value. So I'm going to collect all those final values, those final heterogeneity scores, and I'm going to eventually perform a comparison later in the presentation to show how much worse things can be. So let's talk about the politically entrenched scenario. Now, imagine for this scenario that you spent your life developing political opinions, and you didn't have the use of social media. because maybe it wasn't invented until 2004. And so once you learned about social media, you were already well entrenched in your political opinions. Now, the intervention that I'm going to describe here is to begin the simulation in where no sharing occurs, and then after 1,000 time ticks, I'm going to turn sharing on. And we're going to observe a much greater fall off in heterogeneity. So the first arrow here points to the time at which I turn the sharing on. And you might be wondering, well, why is it not a flat line up until that point? And the answer is it's the proximity network, the bumping into one another, that agents are just, they casually encounter one another and they do talk to one another. But at time equals 1,000, I enable the social network so that agents are able to share messages across longer distances than just proximity. And here we see the corresponding time point where the precipitous fall off in heterogeneity begins, and you see where it ends up is a pretty low value. So I actually have a very basic comparison here. So heterogeneity is significantly lower in the entrenched scenario. I wanted to be able to make that claim with some kind of statistical confidence. And the basic method for accomplishing this is to use NetLogo behavior space to run each of these simulations repeatedly. For expediency, I did this one 30 times. The difference is so huge that that's all that it took for it to be significant. And I obtained a distribution of heterogeneity in each of those scenario runs. And you see the box plots here. The entrenched values are much lower than the unfriending conditions. So that's actually the case where the friendships are turned on later in the game actually produces worse outcomes than when the friendships are cut. To do an actual significance test, this is a linear regression representation of t-test. It's just a basic t-test, but and the scale itself is not especially meaningful. I could have scaled this between 0 and 1. The important part is that it's a significant difference, and the unfriending scenario coefficient is way higher in terms of heterogeneity. I have a couple of other kind of interesting scenarios where there's no intervention. This is just an outcome that I observed. And I call this the heavy politics scenario, where there's a lot of petitions, a lot of speech, and there's some kind of healthy political discourse in this kind of scenario. There's a lot less, relatively speaking, social sharing that occurs, but the heterogeneity of each party never falls off. The friendship ties remain intact. And I think consequently, the cultures within the two parties never diverges in any significant sense. And one of the ways that this kind of scenario can occur is when multiple of these political leader agents happen to be in the town square and they happen to witness an event. So you see here. Political speech is kind of high. Petitions are even higher, but the final heterogeneity value is also quite high. Now, I call this fourth scenario the disconnected elite. This is another emergent scenario where political speech is essentially one-directional. There's lots of petitions. There's not a lot of speech coming back from the politicians. The friendship networks are intact, and you can see that here I've pointed out the amount of political speech is way, way, way lower in a relative sense than the previous scenario. Nevertheless, heterogeneity is intact. Between both parties, heterogeneity stays pretty high. So, okay, let's recap before we get to the discussion. So I built an environment here that supports cultural dynamics. The independent variable for this work is the network intervention. That's the thing that I'm doing. That's the exogenous shock that I'm delivering. And the dependent variable is how culturally similar are the agents after a period of time. This is how homogeneous are the agents. And I turned the social network on and off, and I observed the effects on cultural heterogeneity. And the short version is that interventions increase homogeneity. The culture remains stable when social and political networks are intact. Okay, well, why did I do this? So one of the reasons for doing this as a simulation instead of using actual behavioral data, so first of all, this is based on research conducted with behavioral data, but it's pretty hard to obtain real unfriending data from the world because an approach that would use Twitter would repeatedly hit their REST API. And when you do that, you've got to be really cognizant of the limits that Twitter imposes upon the use of their API. So in practical terms, this means there's a maximum number of users that you can scrape in any given day. And to create a time series of unfriending data, you're going to need to hit that endpoint a lot of times in a lot of days. And it just means that the total size of your sample is going to be limited according to these rate limits. And incidentally, this is a problem that the Twitter fire hose can't help with. That only provides unlimited tweets in real time. What I'm talking about is a network characteristic that has to be inferred by repeatedly querying the Twitter endpoint. So in this sense, my simulations just are a really practical alternative. So I want to ask the question, is politics downstream from culture? Now, that's a claim made by Andrew Breitbart when he was founding Breitbart News. And to the extent that the preferences and the social dynamics that I'm exploring within these simulations is influenced by the network topology, then it really does seem that by changing the culture, you ultimately change the political landscape. It's, of course, a synergistic effect in which political culture changes culture, and culture then in turn changes politics. So I don't think they're separable in that sense. But I do think that these phenomena can be directly observed. And what I have an image of here is an instance of what I think is a subculture that is pretty inaccessible to people who are not familiar with the jargon or the lingo and the way that people speak in anonymous message boards. So this is a picture of QAnon, which comes off of 4chan and 8chan. And you can see some string of symbols. So IDEN reconf v11.9 sequence attack. Anticipated, coordinated. Why are they continuing? Internal. Okay, so this is in some ways kind of babbling, but in other ways there is actually a structure. There are commonalities to these posts that occur across time, and you can think of this as a message which is able to be decoded by the types of agents, or in this case, actual people who have preferences and who have familiarity and who are acclimated and accustomed to consuming this type of communication. We're discussing multiple network layers here. We have social and political networks that are overlaid on top of one another onto a single agent population. And in real life, we are actually connected by many more networks than these two. Just a few examples are the family and heritability and genetic network. Another example is academic and professional networks. It matters who you went to elementary school with, who are your childhood friends. It matters who you work with at your business. It matters who you talk to after work. And then there's also a really interesting set of crowd phenomena that occur. So maybe a quick word about homophily. Homophily is the word that is used to describe a characteristic that many social scientists have observed in social network analysis, in which people or animals appear to show some preference based on similarity. And I'm suggesting that these cultural preferences are one way to cause homophily to emerge without explicitly coding that homophily into the simulation itself. So, for example, I have not encoded within the agents any behavior of laziness or any notion of favoritism or racism or physical similarity. Everything is mediated through the preferences that agents have for memes, the memes that they share, and then the memes that they are exposed to. So when it comes to running all these simulations, I like to think of this as being analogous to the idea of possible futures, unexplored futures. And we could even conceive of this in some kind of science fiction multiverse sort of conceptualization, in which all of these real futures exist in some superposition. And when we observe a future, that is to say, when we actually live in time, we go forward in time and we cause an observation to occur within our reality, then perhaps we are collapsing this superposition into a single definite state that applies to our actual reality. Now, I think this is a cool thought experiment. I don't think that's actually what's going on in these simulations, but it's a pretty neat way to think about it. So what are the next steps for all this? Well, so certainly there are all sorts of different interventions that we can imagine, different intervention schedules, different network layers could be added to this, better simulation parameter calibration. So what that means is I have a pretty good model of sharing. Maybe I would like to include a better model of emotional state. So maybe a model of fear or a model of humor would be, or disgust actually, would be really interesting for this type of work. And along those lines, I would like to extend the simulations with more demographic or psychographic information. So I'm going to be wrapping up my PhD work over the summer, and that's part of why I'm uploading this video. And I would love to hear feedback on this work. Thank you very much.